Now let us learn the ray diagrams of images formed by curved mirrors. In previous class we have discussed the light rays which are used to draw ray diagrams. By using any of two light rays we can draw these ray diagrams. We have two types of curved mirrors. One is concave and second one is convex. We can place the object in different places in front of a concave mirror or convex mirror. So these are the important positions of the object in front of a mirror: at infinite distance, beyond center of curvature, on center of curvature, between center of curvature and focal point, and on F, between pole and focal point. If any object placed in these positions in front of a mirror, how the image is formed, whether the image is enlarged or smaller, diminished or bigger. So let us learn all these things by drawing the ray diagrams if the object is placed in these positions. So first let us draw the ray diagrams in case of concave mirror. So if you place an object in various places in front of a concave mirror, so where the image is formed, first come to if the object is at infinite distance from the concave mirror. We know that this is a concave mirror and here is pole, focal point and center of curvature. If the object is at infinite distance, generally the light rays coming from the object at infinite distance, the light rays are parallel to the principal axis. If the light rays are coming from the sun is very far from the earth, so the light rays which are reaching the earth are taken as parallel. So here the from infinite distance the light rays coming and incidenting on the concave mirror, they are parallel to principal axis, then they get reflected by the mirror, and after, we know that the parallel light ray, after reflection the light rays passes from the focal point. Here all the reflected light rays passing from the focal point, which means all the light rays intersecting, reflected light rays intersecting on focal point or foci. So the light rays after reflection, where they intersect, there the image is formed. Okay, in case of the object at infinite distance, the image of that object is formed at focal point. The image is point image and the image position is on on F, on focal point. So this is the ray diagram for the object which is at infinite distance from the curved mirror. Now let us draw the ray diagram of the object which is placed beyond C. So this is the concave mirror. Beyond C means after center of curvature. Pole, focal point and center of curvature. Here a object is placed after C, then where the image of that object is formed, then how the image is. Yeah, here I am taking two light rays to draw the ray diagram for this. First light ray is parallel light ray. So we know that Always the parallel light ray after reflection passes from the focal point. This is a reflected light ray. And the second light ray I am taking, which is passing from the focal point. So two light rays are taking from the tip of the object. Then the light ray which is passing from focal point and inciding on the concave mirror, after reflection it becomes parallel to the principal axis. So here these two reflected light rays are intersecting here. So here the image is formed. So the object which is outside C, after beyond C, then the image of that object is formed between F and C. Here we can observe the image is inverted. Inverted image is formed, and you can observe the size of the image is smaller than object. So the image size is diminished or smaller image, and the position of the image is between F and C, between focal point and center of curvature. And one more point, that is the image is real image. So whenever the reflected light rays intersects, they forms the image on the screen. The image which can be caught on the screen, that image is said to be real image. So this is the ray diagram from the object which is placed beyond C, after C. So the characteristics are inverted image, diminished image, and between focal point and center of curvature, that image is real image. The image which is caught or captured on the screen, that image is said to be real image. If you place a screen here, then the image is focused or formed on that screen. So this is about the ray diagram for the object is placed beyond C or after C. Now come to the next one. If the object is placed on center of curvature, then how the ray diagram? So this is pole, focal point and center of curvature. Here the object is placed on center of curvature itself, the object is placed. Then the first light ray I am taking parallel to principal axis, then it after reflection it passes from the focal point, and the second light ray which is passing from focal point and incidenting, and after reflection it becomes parallel to the principal axis, then both light rays are intersecting here, then the image is formed here. Okay, the position of the intersecting point where the reflected light rays are intersecting, there the image is formed. So if the object is placed on C, the image also formed on the C. So the image is inverted, and the size is same size. The size of the image and the size of the object is same when you place the object on C. And next, the image is real image. So real image, the position of image is on C itself. So this is the ray diagram about the object is placed on C. So the inverted image, same size, and a real image, because this image can be captured on the screen, and the position of the image is on C itself but inverted. So this is ray diagram for the object placed on C, center of curvature. Now come to if the object is placed between C and F. This is the concave mirror, focal point, center of curvature and pole. The object is placed between F and C. The parallel light ray incidenting on the mirror, and after reflection it passes from the focal point, and the second light ray by passing the focal point incidenting on the mirror, after reflection it becomes parallel to the principal axis, and two reflected light rays intersecting here, the image is formed here. So this is the ray diagram for the object placed between F and C. So what are the characteristics of the image? So the image is inverted. The image is inverted, and next the size of the image is bigger than the object. So enlarged image. Enlarged means the bigger image, and the image is real because these two reflected light rays are intersecting here, so that image is real. Then the position of the image is after C, so level or beyond C, after center of curvature. So this is about the ray diagram if the object is placed between C and F. So that image is inverted, enlarged, real image, and after C, the image position is after C. And next, what happens if the object placed on F? So here P, this is the mirror, and F, C. Now the ray diagram we are going to draw. The object is placed on F. Then what happens? The object is placed on F. The first light ray parallel to the principal axis. After reflection, it passes from focal point, and I am taking the next light ray which is incident at pole with the same angle, it get reflected. Then we can observe these two light rays are parallel, reflected light rays are parallel. So then whenever two light rays are parallel to each other, they don't intersect. So image is formed at infinite distance. The formation of image is infinite distance. We can't say where the image is formed because these two reflected light rays are parallel to each other. So we can't say whether the object is enlarged or inverted because the image is formed at infinite distance. And last one, the position when the object is placed between P and F. Then this is very important position in case of concave mirror. In all these cases, in all above cases, the concave mirror forms mostly real images. All the light rays are converged and intersects at particular point. That's why concave mirror also said to be converging mirror, because mostly the concave mirror converges light rays. That's why the concave mirror also said to be converging mirror. So in this case, the concave mirror diverges the light rays only in this case, and this case is very important, and this case is also used by the dental doctors to observe our teeth by placing the concave mirror inside the mouth, and the teeth will be placed in front of that mirror between pole and focal point. then they observe the teeth. So let us draw the ray diagram for the position of the object whenever it is placed between pole and focal point. And this is the concave mirror, and pole, focal point and center of curvature. If I place an object between pole and focal point, the first light ray nothing but that light ray is parallel to the principal axis, and it is after reflection it is passing from the reflected light ray passes from the focal point. Then the second light ray, you can take the light ray which is passing towards the center of curvature. So if it passes, it intersects on the mirror, and again it get reflected by observing same position. Or you can take a light ray which is intersecting the mirror, instanting at the pole, then with same angle it gets reflected. Then you can observe all these reflected light rays. One is parallel light ray passing from the focal point, and the second light ray passing along with radius of curvature or radius, and instanting on the mirror, and it again bouncing back with following the radius itself. And if the light ray instanting at pole with the same angle, the light ray get reflected. So if you observe these light rays, they are diverging. These reflected light rays are diverging. If you observe these two light rays from here, you feel that these two light rays are coming from here. So these two light rays and this light ray also, these three light rays are coming from here. So this image is said to be virtual image. Okay, here these light rays are diverging. If you observe these light rays, you feel that the image, the object is placed inside the mirror. Okay, so this image cannot be captured on the screen. We can only observe this image in the mirror. So the image which cannot be caught on the screen, that image is said to be virtual image. The image which we can see in the mirror but it cannot capture on the screen, that image is said to be virtual image. So concave mirror forms a virtual image whenever the object is placed between pole and focal point. And the first characteristic of the image for the object placed between P and F, that is virtual image, the size of the image is enlarged, bigger than the object. So enlarged image is formed, and the image is erect. It is not inverted. In previous ray diagrams we have observed inverted image, but here the image and object both are same. So erect image. So then the position of the object image is inside the mirror. The image is formed inside the mirror. And this case, whenever the doctor keeps our teeth between the pole and focal point for a concave mirror, then our teeth, the size of the teeth increases. Then he can observe what is the problem inside. So this is very important case, the ray diagrams of concave mirror. Okay, next let us draw the ray diagrams formed in case of convex mirror. We know that the convex mirror, it has coated with silver inside. then outer part acts like a mirror, pole, focal point and center of curvature. Focal point and center of curvature is opposite to reflected part. Then if you place a object in front of a convex mirror, then what happens? A parallel light ray which is incidenting on the mirror, then what happened? It get reflected such that it appears to be coming from focal point. The light ray, the reflected light ray appears to be coming. If you observe this reflected light ray from here, you feel that the light ray is coming from focal point. In previous class we have discussed these light rays which are used for ray diagrams in case of concave mirror as well as convex mirror. Once observe that video. And this is the first light ray. The reflected light ray seems to be coming from focal point, and the second light ray I am taking which is incidentting at pole with the same angle, it get reflected. This is a reflected light ray, and if you observe this light ray which is appears to be coming from here, both reflected light rays are appears to be coming from this particular point, and here the image is formed. So in case of convex mirror, wherever the object is in front of that mirror, the image is always formed between F and P and diminished. The position of image is between F and P, and always it forms diminished image, smaller image than the object, and it's erect image, it's not inverted, erect, that image is erect just like the object, and this image is virtual image. That image cannot be caught on the screen. Okay, so this is about the ray diagrams of convex mirror as well as concave mirror.